Class 12th Chemistry, Chapter 3, Electrochemistry, YouTube channel Lingareddy Chemistry JEE NEET. Electrochemistry Part 2. The main topic is electrode potentials. The subtopics are oxidation potential, reduction potential, standard electrode potential, reference electrode, hydrogen electrode, calomel electrode, electromotive force of a cell, galvanic cell or voltaic cell. Electrode potential. See, what is electrode potential? When an electrode is in contact with the solution of its ions in a half cell, it has a tendency to lose or gain electrons, which is known as electrode potential. You can see in the right side figure. Here zinc sulphate solution, the zinc rod is dipped. So the zinc sulphate solution, this zinc plus 2 ions are on the surface of zinc rod. So these are generating positive charge outside. On the zinc rod it has negative charge. So here two conditions generated. It may zinc plus 2, it may convert into zinc, or zinc is converting into zinc plus 2. So in between zinc plus 2 and zinc, the potential difference is generating, that is only electrode potential. It is an intensive property, that means independent of the amount of species in the reaction. Is it clear? These are oxidation potential and reduction potential. Oxidation potential means the tendency to lose electrons. Oxidation means obviously losing electrons. Like in oxidation, where it takes place at anode. So the tendency to lose electrons at anode is known as oxidation potential. This oxidation potential of a half cell is inversely proportional to the concentration of the ions in the solution. Next, reduction potential. The tendency to gain electrons at cathode is known as reduction potential. According to the IUPAC convention, the reduction potential alone be called as electrode potential unless it is specifically mentioned. This second point is important. Wherever the electrode potential value is given, that value we have to consider that is reduction potential value only, unless they mention that it is oxidation potential. Wherever in the statement in any book, wherever you are reading electrode potential value is some x, that means that is reduction potential value only. Next, what is the relation between E reduction potential and E oxidation potential? The numerical value is same, only the sign convention is different. You can see here E reduction equal minus of E oxidation, minus of E oxidation. Next, measurement of electrode potentials. How to measure this electrode potential? For that we need a reference electrode. What is the reference electrode? See, this is the reference, one of the reference electrode. It is also known as hydrogen electrode. The electrode of known potential is called reference electrode. It may be primary reference electrode like hydrogen electrode, or a secondary reference electrode like calomel electrode. Two types of electrodes are there. One is primary and secondary. This primary example is hydrogen electrode. For secondary is calomel electrode. Standard hydrogen electrode, also known as a normal hydrogen electrode, SHE or NHE. This value is 0. With respective of this value only, the others electrodes potential value is decided. This is used as a reference to measure the electrode potential of the other cells. Some important half cells, that is only hydrogen electrode as well calomel electrode. This hydrogen electrode, what we are taking, it is a gas actually, so that's why we are taking platinum rod. On the platinum rod, hydrogen is adsorbed. You already seen that figure. The platinum rod is dipped in, you can see here, this is the platinum rod dipped in the HCl solution. Here H plus is there. On the platinum rod, hydrogen gas is adsorbed. See here we are sending the hydrogen gas. So this H plus and hydrogen, these both are in equilibrium. So this H plus, it may change to hydrogen gas or hydrogen may change to H plus ion. That is depends on the other attached electrode. Similarly, calomel electrode also is there. That is we are using mercurous chloride and HCl. Next, standard electrode potentials. What are the standard electrode potential? The potential of a half reaction measured against the standard hydrogen electrode under standard conditions is called the standard electrode potential for that half cell reaction. Standard conditions. What are the standard conditions? 1 molarity, atmospheric pressure is 1, then temperature is 25 degrees Celsius. Then this standard electrode potential value is denoted by E0, E0. See here, in this cell we made a cell with the help of one hydrogen electrode, the other one is copper electrode. Copper electrode, here hydrogen electrode. This hydrogen electrode is a standard electrode as well a reference electrode. This value is 0 potential. This hydrogen electrode potential is considered as 0. Now, when we make a cell with the help of hydrogen and copper electrodes, our voltage is showing 0.34. This value is at standard condition. Already standard condition we discussed. At standard condition, the value is 0.34. That means this value is assigned to copper. This value is assigned to copper. Now, what is the sign convention here? Positive. Why it is positive? See here, copper is taking electron. Copper is taking electron. This is the reduction potential value, Rp, reduction potential value. That means with respective of hydrogen, the copper is taking electrons with 0.34 times 0.34 times efficiently, we can say, or tendency is 0.34 times is higher. The final conclusion is the copper is taking electron 0.34 times efficiently with respective of hydrogen electrode. So this is the this reaction is reduction reaction. See, copper taking 2 electron and forming copper. This is the reduction reaction. This value is reduction potential value. Reduction potential value. So what is this meaning indirectly? The ability of reduction reaction. The ability of reduction reaction, we can say. The tendency of. See here, many metals and non-metals, ions, electrode potential values given. See here, fluorine value. Fluorine taking 2 electrons and forming F minus. This tendency is 2.87 times. How this 2.87 value is assigned this? With respective of hydrogen, 2.87 times efficiently this fluorine taking electrons. We can understand in that concept. See, hydrogen considered as the 0. All the above these ions and metals and non-metals, those are taking electrons. Of course, there is no metals, all metal ions are there. Down, these values are showing with negative sign. This negative sign means, suppose here last one is the lithium is there. The lithium is value is minus 3.04. Reduction potential value given in the negative sign. That means this lithium taking electron tendency is minus 3.04. That means it is not taking electron, it is losing electrons. So, if you talk about oxidation potential, lithium oxidation potential is 3.04. That means lithium 3.04 times efficiently losing electron. In case of reduction potential value, the same value with negative sign we are showing. So, here important 2 points are there. So, this higher positive values are there means those are having higher tendency to accept electron from other substances. So, these are the good electron receivers. So, these are acting as stronger oxidizing agent, OA, stronger oxidizing agent. Now, the lower one is minus reduction potential values, indicating that those are not ready to take the electron. Generally, those are losing electrons. These are losing electron means these are acting as a good reducing agents. These are good reducing agents. So, you can see here stronger reducing agents. Lithium plus, sodium plus, magnesium plus 2, these are stronger reducing agents, these metals, and fluorine, H2O2, KMnO4, these all are acting as stronger oxidizing agent. Next, electromotive force of a cell. What is electromotive force? What is EMF? EMF is the maximum potential difference between two electrodes of a galvanic cell or voltaic cell. This quantity is related to the tendency for an element, a compound or an ion to acquire, that means gain or release of electron. You can see here the figure. This is the Daniell cell. Daniell cell means the cell which is made by copper electrode and zinc electrode. See, salt bridge is there. So, at standard condition means at 25 degrees Celsius and 1 m concentration and pressure 1 atm. At that conditions, this zinc and copper electrode cell, that is called Daniell cell, is producing 1.1 voltage. 1.1 voltage it is showing. Then here cell notation. How to write cell notation? In the cell notation, the middle part 2 slash is indicating it is a salt bridge. This is indicating salt bridge. The right side, generally we are writing reduction potential, reduction half cell. Left side we are writing oxidation half cell. Right for reduction. If you remember right for reduction, obviously left is oxidation. Then how it is changing? Always the terminal in the last edges solids are present, always in the cell notation. The last is terminal position here copper, here is a zinc. Terminal positions always we are writing solids. This is the one rule. Here copper also solid. And what is giving the information here? This cell notation is completely giving the chemical equation information. See, zinc is converting into zinc plus 2, that getting oxidation, then copper plus 2 undergoing reduction forming copper. So, this is the cell notation. Now, E cell value is a formula. E cell equal E right minus E left. E right minus E left. So, what is the E right here? This is a copper reduction cell minus E left zinc half cell. So, copper plus 2 to copper, zinc plus 2 to zinc. You can see here the copper plus 2 to copper formation ability is 0.34. This is the reduction potential value of copper, 0.34. The zinc getting oxidation is 0.76 times. So, oxidation potential value is plus 0.76, but reduction potential value is minus 0.76. Just you put those values here, 0.34 and minus of minus 0.76, that equal to 1.1. So, like this we can calculate the EMF of a cell. This is the standard EMF of a cell, because we are taking at standard conditions. We can solve one question. The standard electrode potentials of zinc plus 2 to zinc and Ag plus 2 to Az given these values respectively. The standard potential of a cell we have to calculate. Tell me here, zinc plus 2 to zinc and Ag plus 2 to Az. So, which is oxidation and which is reducing? Obviously, Ag plus 2 to Az is undergoing reduction, zinc will be undergoing oxidation. Zinc undergoing oxidation. So, what is the formula? E naught cell equal E reduction minus E oxidation, E right minus E left. So, E reduction silver value minus zinc value. The silver value is around 0.799, then zinc value is minus 0.76. So, minus 0.76. So, minus into minus it becomes plus. So, this 0.03 is wrong. So, total value is 79, means the 5, 7 plus 7, 14, 15, 155. That means 1.55 volt we are getting, 1.55 or 1.56. So, the option is A, 1.56. It is not 0.03, it is 1.56. E reduction minus E oxidation, E reduction minus E oxidation. Once again you can refer. Which is the strongest reducing agent? Strongest reducing agent, that means it should lose the electrons. It should lose the electron. Which can lose the electron? Generally S block elements are losing electrons. So, the reduction potential value should be negative, the negative highest value. See, this is the negative highest reduction potential value. That means oxidation potential value is highest. strong reducing agent. Reducing agent means it should lose the electron. Of course, losing tendency is more. Taking tendency minus means losing tendency, that is. So answer is zinc. Next, which is the strongest oxidizing agent? Oxidizing agent, it should be receive the electron from other substances. These all values are tendency to accept the electron. So highest acceptance is for Fe+3. So it is acting as good oxidizing agent, that is Fe+3. What is electrode potential and why hydrogen electrode potential is 0? Because that is taking as a reference electrode. And what is electrode potential is potential difference between a solution and electrode. Is EMF. EMF is intensive or extensive? It is intensive property. Negative electrode potential value indicates losing electrons or gaining electrons. See, negative electrode potential value is generally indicating losing tendency. Thank you.